Okay, welcome to the lecture about solving rational equations. So, a rational equation is an equation where you can see rational expressions or rational functions on either side of the equality sign. For example, 5 over x minus 2 is a rational expression on the left-hand side. 4 over x plus 3 is another rational expression on the right-hand side. Therefore, this is a sample rational equation. Or sometimes these rational expressions may have like quadratic numerators or quadratic denominators or any kind of polynomial. So sometimes it is like we are adding or subtracting two rational expressions, and that is equal to some number or some other expression. So there's all sorts of different rational expressions, rational equations out there, and we just want to know how to quickly solve them. One of the methods you can use, it's a fast method, it's called cross multiplying. So here we can quickly do this cross multiplication. We can say 5 times x plus 3 equals 4 times x minus 2. But I want us to do this cross multiplication with understanding. It's a shortcut, quick way of solving equations, but we have to know exactly what we're doing. What we're doing here, to tell you the truth, is actually we are multiplying both sides of the equation by the LCD, lowest common denominator. So here, between the two denominators, the LCD is actually x plus 3 times x minus 2. That's the LCD. So we are multiplying both sides by this LCD with the assumption that x is not equal to negative 3 and x is not equal to 2. Those are the roots of the denominator. So you should set the denominator is equal to 0, okay? And then you should get non-permissible values for the denominator for every single rational function or expression. And x minus 2, if it's not 0, can't be 0. That means x can't equal to 2. So with this assumption, with this restriction stated that x cannot equal to 2, x cannot equal to negative 3, because think about it, if it is, then we don't even have defined rational expressions on either side of the equation. When you have something undefined, how do you want to solve an equation which is undefined? So with that in mind, we're going to multiply both sides by LCD. So we're multiplying left side by x plus 3 times x minus 2, and you do the same thing here. Okay? So that's what we're doing basically. But then the thing is that x plus 3 or x plus 3, they cancel out each other, don't they? And we said that they're non-zero. And here x minus 3 and x minus 2 cancel out each other. So look what is left over. 5 times x plus 3 right there. 4 times x minus 2 right there. I told you at the very beginning. So it is super fast, very convenient, fast, efficient method. Cross multiplication. But we have to know what we are doing. Okay, we have to know where it's coming from. Okay, after you know where it's coming from, after you state the restrictions, then you can definitely use that to quickly solve the equation. So now the rest is piece of cake. This is 15, 4x minus 8. So we have 5x minus 4x, negative 15 minus 8. So that would be negative 23. So we solved the equation. We got the final answer, negative 23. Okay. So in only 2-3 lines, you can, solve the rational equation. This is another one, for example. So we can, again, do the same thing. If you want to solve it quickly, you can do the cross multiplication, but you have to understand the restrictions. You have to understand what you're doing, basically. You're multiplying both sides by the LCD. In this case, x minus 6 times x plus 10 is the LCD. Okay? So LCD is x minus 6 times x plus 10. The restrictions, so restrictions on the variable is that x cannot equal to 6, x cannot equal to negative 10. These are the roots of the denominator. Okay? Numerator, it's okay to be 0, not the denominator. So having said that, then if you multiply both sides by LCD, you will end up with the same result that I obtained by cross multiplying. Okay, the result is the same. But if you know where it's coming from, then you can use it. But if you don't know where it's coming from and you don't know the restrictions, then don't do that. Okay? All right, so now we have 2x squared, and then 2 times 6 is negative 12, and negative 5, that's negative 17x plus 30, which is x plus 10. So 2x squared minus 18x and plus 20 equals 0. All the coefficients are even numbers. I divide both sides of the equation by 2. And we have the right to divide or multiply both sides of any equation by a non-zero number, in this case 2. All right, so I ended up with x squared minus 9x plus 10. So this time, I didn't end up with a linear equation as it was before. In this example, I ended up with a quadratic equation. Now, is it possible to solve it by factoring or using quadratic formula? Yes, of course. You can use any method if you like it. So 10 times 1 is 10. Now, I don't think we can factor this because we need to find two numbers that add up to negative 9, and their product is actually 10. But I don't think we can do that, can we? So x squared minus 9x plus 10 equals 0. Two numbers that add up to negative 9, but the product is 10. So I don't think we can factor it. So if we can't factor it, then we are going to use quadratic formula. Factoring is faster if it works, of course. If it doesn't, then it doesn't. So we have the quadratic formula, b squared minus 4ac divided by 2a. So we have 9 plus minus 81. That's b squared minus 4ac would be 40. 4 times 10 is 40 divided by 2. So we get 9 plus minus square root of 41 divided by 2. So we ended up with two solutions. X sub 1 is 9 plus root 41 over 2. The other one is 9 minus square root of 41 over 2. So we end up with two irrational solutions for this rational equation. If it was factorable, okay, then you could solve it by factoring. It will be faster. If it's not factorable, it's not the end of the world. We can always use quadratic formula. And even if sometimes the discriminant, if that is a negative number, then you can say there is no real solution actually. The first one we are going to try. The first one, it's the sum of two rational expressions is equal to 3. But this one is very easy because the denominators are actually the same. So the LCD is actually x plus 1 itself. It's just like saying 2 times 1 over x plus 1 plus 1 times 1 over x plus 1. So 2 plus 1 is 3. So this is basically 3 over x plus 1 equals 3 if you just simplify it. Okay? And then if you multiply both sides by x plus 1, you will end up with the same result that you obtain by actually cross multiplying. Now the denominator of 3 is 1 obviously. So we end up with x plus 1 equals 1. And from there, x equals 0. And when you think about it, x equals 0 is the right answer because when you plug in 0 here, 0 there, 2 over 1 plus 1 over 1 equals 3. It satisfies the equation. So that's just another easy example right there. The next one here, we have another rational equation to solve. So again, if you go by the cross multiplication method, we get x squared times 36 minus 2x, okay? And again, we're going to say the denominators are not 0, so x squared cannot equal to 0, which means that x cannot equal to 0, and 10x plus 56 cannot equal to 0, which means x cannot equal to 5.6 actually. These are the restrictions, right? Now you can multiply both sides by the LCD, lowest common denominator, which is x squared times 10x plus 56, or do it faster, you can just do it by cross multiplication, as I already started doing it. Now here you do the FOIL, so 220x plus 22 times 56. Let me see if you have the calculator, you can do it. 56 times 22, that's 1232. So 1232 minus 10x squared minus 56x equals 36x squared minus 2x cubed. So we end up with a cubic expression, cubic polynomial, I guess. So let's see what's going to happen. I'm going to move that here. So 2x cubed on the left. Then we have negative 36, negative 10, that's going to be negative 46x squared. Negative 56 and 220, that's 164. So 164x. And the only constant is 1232 equals 0. Now all these coefficients are even numbers divisible by 2, obviously. So we can divide both sides of the equation by 2, and we get a cubic equation for the first time. So 82, that's 616 equals 0. Okay, so we got a cubic equation. All right, here we got a linear equation, it was easy. Here we got a quadratic equation. Here it was like very simple, and this one gives us a cubic equation. So solving a rational equation leads us to solve a cubic equation. So if we didn't know how to solve cubic equations, if we didn't know about factor theorem, then we couldn't solve this rational equation. I like this question because this is like killing two birds with one stone. You're checking to see if the students know how to solve cubic equations as well as rational equations. Okay, so here we have to look at the divisors of 616. So that's plus minus 1, plus minus 2. There's a whole bunch of them, plus minus 14. I call this f of x, and to make a long story short, f at 14 will give you the 0 if you try it. If you try different numbers, different divisors of the constant term 616, you will see that f at 14 will be 0, which means that x minus 14 is a factor of f of x. So we start dividing. We are going to use synthetic division here. So if you divide this polynomial by x minus 14, I put the root of the divisor 14 on the left hand side. Then we get 1 times 14, 14. You're going to add them up. You end up with negative 9. Times that is going to be negative 9 times 14 is going to be negative 126. If you add them up, it's going to be negative 44. Multiply negative 616. As we expected, we end up with a remainder of 0. So now we have x squared minus 9x minus 44. This is the quotient. And then times the divisor, which was x minus 14. This is the f of x, which is supposed to be equal to 0. So obviously, one of the answers is x equals 14. So I'm going to say if x minus 14 is 0, one of the answers is x equals 14. Or if this quadratic trinomial is 0, then in that case, we can use either factoring or quadratic formula. I don't think we can factor it because I don't think you can find any pair of numbers that add up to negative 9, but the product is negative 44. You can't find such pair. Therefore, we're going to use quadratic formula. So it's going to be negative b, which is 9 plus minus square root of b squared minus 4ac would be 257 divided by 2a, but a is 1. So we end up with 2 other roots that are irrational. So one integer root, 14, and 2 other irrational roots is what we got. So this rational equation has 3 real roots basically, and we found all 3 of them. Okay, so let me separate this solution from the others and this one so that when you're taking notes, you can easily see the solutions. I suggest you try these solutions by yourselves, and And by just doing some questions, you will become very fluent in this. This topic is not that difficult. This was maybe the hardest question, and the reason why it was hard because it led us to a cubic equation. Otherwise we had linear equations and quadratic. Those are easy to do. So keep practicing and keep well. Thank you.